Welcome to the course on Artificial Intelligence in Industrial and Management Engineering. I am Dr. Pravar Pratap Singh and we are co-teaching this course with Professor Deepu Philip. We have till now in this course we have covered different aspects of artificial intelligence. In the previous week we have covered the basics of machine learning, like what are the different kinds of machine learning and how can we utilize them in industrial engineering aspects. Today we will start a new topic that is named as neural network, and this is the foundational concept for all the different kinds of advancements in the domain of artificial intelligence that we see or hear these days. So, let us start by understanding what is a neural network and how we can utilize this in our domain. So, nature inspired countless inventions and brain architecture can also inspire to develop intelligent machines. And these artificial neural networks (ANN) are inspired by networks of neurons in our brains. So, this foundational concept of neural network is based on the network of neurons that we find in our brains. So, it has its roots in biology of humans. Now, ANNs have deviated from its biological inspiration. So, although it is inspired by the network of neurons, but they have significantly deviated from the biological inspirations. So, we do have different kinds of inventions like airplanes. So, airplanes are inspired by birds or other flying creatures, but still the design of airplanes, you can see that the design of airplanes, the wings of those airplanes do not work similar to how the wings of birds work, right. So, they do have some deviations from their inspiration. Similarly, here we have ANNs that are inspired from the network of neurons, but they are significantly deviated from their biological inspirations. Now, these ANNs are the core of deep learning. So, we have already discussed what is a learning in the aspect of artificial intelligence, but today we will understand what is deep learning. We all have heard about deep tech, right? Deep tech. So, the foundational concepts of deep tech lies in artificial neural network, and how do we make our machines learn through large data sets with and try to learn those things that are hard to learn by a machine. Those concepts and what are the foundations of those concepts are covered today, and these are covered under this deep learning concept. So, under these ANNs, what we can do? We can do classifications in large data set of images. we can do speech recognition, right? Or we can also develop recommendation engines. So all these applied areas come under deep learning technology. Okay. Now let's talk about how these artificial neural networks got developed. So we will discuss about a timeline since 1943. McCullough and Pitts, these two people proposed that biological neurons can act as the computational units. So these biological neurons can act as the computational units was discovered and was proposed in 1943 only. For what? To perform complex tasks. Okay. Now, how do these biological neurons can perform these complex tasks? They can utilize propositional logic that can explain the model. So we have already covered an introduction to propositional logic in this course, right? So these complex tasks by these neurons, proposed neurons, can be done by utilizing these propositional logics. Now again in 1960, researchers expected building intelligent devices very soon. But these expectations failed. So here comes the first AI winter. Why? Because the researchers in 1960 were expecting that they can develop intelligent devices in 1960 itself, but they failed, right? So again in 1980, new architectures were developed and better training technology for the models were introduced. Okay. Still, we are trying to develop these intelligent machines, but we are trying to first crack the problem of training these complex models, right? In 1980. Now comes 1990, and instead of getting advancements in neural network, what we achieved in 1990 was technology like support vector machines got popularized, and these SVMs, they are known as SVMs, and these SVMs have far better theoretical foundations than neural network architecture. So after that, currently ANN have widespread implementation for two main reasons. First, we have huge data availability, and for the second one, we have huge computing resources. Okay, so these two things that are available now was not available in 1943, 60 or 80 earlier, right? So these technologies that we have right now, like high computing resources, and we capture large amount of data regularly. So these kind of things make the application of ANNs possible in wide spectrum of domains. Okay. So now let us start understanding how a simple biological neuron works. Okay. So here is a simple demonstration of how these single unit of neuron looks like. So there is something called axon, a nucleus, a dendrite and telodendria, and these are the terminals of a neuron. So let's understand how these things works, because this is the foundation of creating our own artificial neural network. So this biological neuron is composed of a cell body which contains a nucleus. Okay. Then let's come to dendrites. These are nothing but the multiple branching extensions. Axon is the longest extension, and this could be tens of thousands of times longer than the cell body. So this part of the biological neuron is the longest. Okay, axon. And axon tip splits into telodendria. At the tip of these telodendria, at tip of we have synaptic terminals. And what these terminals do, any terminal connect with other things, right? So these synaptic terminals connect with other neurons. Okay. Now one other term is action potential. This is a short electric impulse produced by neurons. Now these synapses or the synaptic terminals, these synapses releases neurotransmitters due to action potential. Okay. On receiving significant neurotransmitters, another connected neuron sends its own signal. So this is how a simple biological neuron works. Okay. So individual neurons behave simply, but a vast network of these neurons can perform complex tasks. Now, since we are trying to develop something artificially to perform complex tasks, so biological neuron fits that model, right? So, in summary, these biological neurons have a nucleus. They have dendrites that are multiple branching extensions. These extensions with these kinds of telodendria and synaptical terminals, they get attached to different neurons in the system, right? And each synapse releases some kind of neurotransmitters due to their action potential. And the once receiving significant neurotransmitters, we get another connected neuron send its own signals. Okay, so this is how things work in a biological neuron. Now, by after getting inspired with this kind of methodology, we will develop our own artificial neural network. Why network? Because we need to perform complex tasks. So now let us understand what is a perceptron model that will lead us to the network of layers for our artificial neural network. So this perceptron model was proposed by Rosenblatt, and he proposed in 1957. What he proposed is he invented the simplest architecture of ANN. Now, in his architecture, input and output of the artificial neural network is a number only. Okay, and weights are associated at each. So let us try to first create a simple perceptron model. Okay, so let us say we have three inputs, and these are the inputs x1, x2 and x3, and each input will gets their own weight w1, w2 and w3. Now we will send the product of input and its weight to this. Okay, and this is what, this is just a linear function. that will calculate our W transpose x plus b. So, this is just a linear function. After calculating these kind of linear functions with our inputs, we will send the signal to our step function. So, step function usually is a non-linear function, and let us say this is a step function. So, after utilizing the step function on these z values, we will get our output. Okay. So, this is the output, which we can also write as step of z. So, this is a complete model, simple model. Now, these kind of units are known as threshold, logic unit, simply known as TLU. So, these are the simple models, and we can write the functional flow of a TLU as first compute a linear function of input. This can be z is equal to sigma wi xi. Okay. Second, we can apply a step function. We can write as hx is equal to step of z. Z is nothing but what we have evaluated in the first step. So, most common step function could be Heaviside function or sine function. We usually also use sigmoid function here. So, Heaviside function definition is something like 0 if z is less than 0 and 1 if z is greater than equal to 0. Okay, and sine function could be -1 when z is less than 0, 0 when z is equal to 0, and 1 is z is greater than 1. Okay. So, these are some of the famous step functions that we utilize. So, now let us try to stop here, and we will continue explaining our perceptron models and multi-layer perceptrons in the next lecture. Thank you.